Okay, so I'll be starting with a basic introduction and let's get started. So, who am I, right? I work at a company called NetCentris as a senior security consultant. I'm in security since 2013, and basically I started with web and then jumped to a lot of other stuff. Now I'm in Android totally, and I study malware samples a lot, and sometimes I like developing it and test it on my local environment. So that is what I do when I am free, and my interest extends from Android to web, and then I'm planning to go to binaries now. So let's see. And before we jump into the core of this talk, right? I want to discuss the goal about that. What exactly I have the goal, right? So what exact it is, I'll be discussing a bit about it, and so it's escalating privileges. So what exactly it is, I'll be giving a little description on it. It's basically you can say when you open this let's say Google Maps, right? When you open Google Maps, you see when you go into the map section and then you start navigating to a particular location, you see a sticky notification, right? How many of you guys are from Android internals? How many of you do Android pen testing here? Okay. And how many of you do Android internals, like the core internals? Okay, okay, I know you. Okay, so basically, when you open Google Maps and you navigate to a particular location, you see a sticky notification, right? Over the top, oh, you see a sticky notification. That is exactly what a foreground notification is. So without a foreground notification, you cannot access microphone, camera, and location. Like any of the data, you cannot access without a foreground notification. And Android comes with some security policies on that. So I'll be bypassing that. I'll be escalating privileges for this foreground notification, yeah, accessing the microphone without even the foreground notification on place. So let's jump into the talk. So before we jump in depth, let's understand what foreground notification is. As I've already said, I'll be jumping from topic to topic for the context of this talk, because at the end I'll be giving a demo on how exactly it is happening. But we'll have to grab some of the basics before we jump. So let's understand what is foreground notification services. Mm, Basically, it's a sticky notification which you get on the top of your notification bar. And the example I gave, right? I'll be casting my Android phone. I have a physical Android device here, and I'll be casting its screen to my computer screen so that you guys can see. Okay, you guys can see the screen, right? So I'll show you what exactly foreground notification looks like. You guys already know it, but let me show you guys how. So I'll be navigating to a particular location. So sorry, internet. I'll have to connect to the internet, otherwise it's not working. So once you start navigating and you minimize the application, right? You see a you cannot quit this notification. You cannot exit this notification. This is foreground notification. So when you even play songs on Spotify, right? You can see once you minimize the application, you'll be able to see a particular notification which you cannot quit, right? You'll have to exit the application, or you have to pause the application, or basically you have to stop the application to get it closed. So this is foreground notification. Why Google Maps is using it? Because they are trying to access your location data, and location is basically GPS is a hardware sensor, right? And that is why the foreground notification is needed. And without the foreground notification, even Google cannot access the basically your location data, your GPS data. So that is why Maps is using foreground notification to access your data. So I'll just close it. So now we know that what exactly the foreground notification is, right? So I'll jump into the talk again. Okay. So let's move to the next slide. This is done. So before even we start, right, we'll have to pick into 2017 back, and there was a release of Android O. It's basically Android 8 Oreo, which have some interesting, very interesting stuff that led to this bypass. And we'll go into the next slides. Basically, on Android 8, right, there was some feature released on Android. It's basically, they call it security feature, and to save your battery, but a lot of security features are also included in it. So it's basically Android background limitations. We'll explore it more. And the major changes on Android 8, right? Oreo was basically background service limitations and the background location limitations. So what exactly Android brought to this particular update? So before, when you want to start a service background, right? Sometimes what you see is basically there are many background services in Android which you can run through app. And to run background services on Android, you'll have, before Android 8, right? It was start service method. You can call it directly, and you can start a background services on Android. So on this update, it do not work anymore. So another update was you cannot run services in background if the app is closed without any foreground notification. So to bypass that, you have work manager, you have other like workers, you can use it, but there is a limitation of 15 minutes where you have to wait for 15 minutes to call your next work. But there's a bypass for it. We'll discuss this later on another talk. But yeah, also the thing is, you can, from the background, even when you close the app, right, you cannot access any microphone, camera, and location without having foreground notification in place. So there is no background work in allowed in Android 8 update. And there are some very interesting things to know about the foreground notifications before exploiting it. So we'll jump into that. So after the Android system creates foreground service, the app gets like 5 seconds, exact 5 seconds to start the foreground notification service. And if you don't start your foreground notification service within that particular time frame, right, the application closes the foreground your service for that particular app. The Android OS already closes your your basically it closes your service. It just kills your service. And So basically, let's see how it actually looks like. So you start a start foreground service call, and then there's a time 5 seconds time frame. You guys have to track on this, because we'll come later how exactly you're exploiting this particular vulnerability. So there's only time 5 seconds time frame, and then you have to start the foreground service. If you do not start the foreground service within this 5 second time frame, right, it do not start. The Android OS kills the service. So any code you run between this start foreground service and then stop foreground service, right? Any code you run between this is a privileged call. So you can access any camera, microphone, or even location data within these 5 seconds. So there are some disadvantages. We'll talk about it, and so let's talk about the disadvantages first. So you cannot access the sensitive data APIs for a long amount of time. For example, you are creating a spyware, right? So on spyware, let's say you are trying to record audio of your surrounding, right? You cannot. As we have already talked, that there's only 5 seconds time frame where you cannot do all your privileged stuff, right? But you do not want your spyware to record for only 5 seconds, right? That is a problem. You cannot record for 5 seconds and just listen to it, right? Because just 5 seconds will not gather much info. So when you are developing a spyware, you need your malware to record all of the stuff around that particular environment, right? So the stealthiness will be done if you use foreground notification to access your microphone. As you have already know that with foreground notification, you can access microphone from the background, and you have the privilege to do that, right? Google do not Google allows it. With foreground notification, you can access your all the other hardware sensors. But if a spyware, from a spyware's perspective, right? If you try to access the location data or the camera data from the background, so there's a problem. You see a notification every time, and it actually kills your stealthiness of the spyware, right? So we'll solve it, but in the upcoming slides. So this is a sample code snippet where you can start the foreground notification, and any code you run between that, right? It has a time of 5 second time frame where you can access the camera, access the microphone, and access the location. So accessing these particular sensors, right, you can do in between this particular 5 second. But like we have already discussed, right, accessing the microphone for 5 seconds is not really worth it. So we'll talk about it. But by now we know, right, that whatever we have to do, whatever the bypass has to be done is between these particular two calls: start foreground service and the stop foreground service. So like I was talking about, this problem before this slide was we can take camera snaps, precise location, for example, if you want to get the camera snaps, right, it can be done within those 5 seconds. You don't need 10 minutes or 20 minutes to take a camera snap, right? You can just call your foreground service, you call your custom function of the camera snaps, and you can just take a snap and stop the foreground service. It will be just as easy as that. So you can do the same for the precise location in short, and it is totally doable, right, under 5 seconds. But when it comes to the long-running tasks, like we have already discussed, you cannot record your microphone for just 5 seconds, right? It's a problem for a spyware, from a spyware's perspective. And you also need the stealthiness. You cannot show the notification to the user, right? So before we jump into the exploit, we'll talk about a little touch of the Android internals. What is an application context? An application context has all the global information available. Every application has activities. Every activities has their own context. So every other different, there could be multiple activities in a particular application, and every activity has its own context. So those activities, those contexts get access to this intents, broadcasts, and activities, launching activities are included. So it basically give access to the all Android core functionalities, and this will be very important to understand the bypass. So yeah, so let's discuss about how the bypass is going to work for the microphone. And like we have discussed, right, the application context is very, very important to understand. So every application has its own context, and we'll be using, when you try to implement the microphone implementation on your code, right, in Java, you do not need to basically implement your own hardware implementation. You have the APIs, the media, there's a API for in Android inbuilt, which is called Android Media API, right? So what you have to do is this is the context application malicious Android app. This is my spyware. What it does is it gives a call to this Android Media API, and both have their different contexts, right? You do not have to control any of the stuff that the media server does, like the recording and the stopping of recording. You just have to pass the calls. So what it does is, sorry. So what it does is, your application starts in context A. It gives a control. Let's say the application is passing a control called start recording, right? The control passes to the Android Media API, and what it does is the Android Media API understands that, okay, I got a call, so I'll have to start the recording. Okay, so it starts, and then what it does, it starts recording and it continues the recording. So after, when you want to close the recording, you will have to give a stop call. It passes the control, and everything is handled by the Android Media API. You do not have to do a custom implementation of the Android start and stop. You do not have to control the sensors. All the APIs are already inbuilt, and these are Android's custom inbuilt APIs. So you do not have to do your implementation on your own. So after you stop it, right, what Android Media API does is it saves to the internal storage. We'll look into it, but this diagram is very, very important to understand the bypass, because we'll be looking into the demo, so you'll understand then how this is useful. So before I jump into the next slide, I just want to know that I just want to let you guys know that how the bypass works. A little bit touch of it, like from when this context A is started, right? When my application starts, the malware application starts. What it does, it starts a foreground notification, and then between the foreground start and foreground stop, it calls this start audio recording call to the Android Media Server, and it stops the foreground notification. So what it does, you get a notification on the very fast phone. Nowadays the phones are very, very fast, right? I bought a very slow phone because so that I can give you a demo on this. So this phone is very slow, so I took it intentionally. So what it does is, the malware application starts a foreground notification service, and what it does, it calls the Android Media Server. Then once the Android Media Server call is done, what it does is closes the foreground notification service. So you don't get a notification for this the audio recording, and also you do not have to record it for 5 seconds because you are closing the notification. But what it does is it passes the control to the media server, right? And the media server has different context, so you don't have to control any of the media server implementation. All of the stuff that recording has to do with, right, it is done by Android itself, and so you don't have to control it. You just have to give the starting and stopping call for the media server, and it will save your MP3 files on your storage automatically. So a little twist is this: whatever we have discussed yet is already fixed, and whatever we have learned so far, right, it's already fixed and do not work. So the CV is 2019-2219. Google rolled out a patch for this in December 2019. Whatever we have discussed do not works. So now we'll jump to the exploit part of it, how we are going to patch it. So so basically, to bypass this, we need a 0-day. That is very, very simple. And the requirements for this bypass, right, is you'll have to know about threads. It's a very, very simple bypass. It's just 5 lines of code, and you'll be able to bypass it. But the implementation of the application is very, very long. But the code where the bypass is working, right, is just of 5 lines. So what is threads? In very simple terms, you will be able to run multiple tasks parallelly without hindering or interfering with other tasks in the same application process. So this is the application process which is being created. Under that, you can create as many as threads you want, depending on the hardware. So basically how we are going to use threads on this particular bypass, we'll see in the next slides. So this is actual, this is what the bypass looks like. These lines are the bypass. This code snippet is the bypass. So what I'm doing is I'm starting a foreground notification service here. So the notification implementation is done in another file, but I'm just showing how the bypass looks like, right? Here's the start foreground notification service. Then you go into there, you create a runnable, you create a thread, and once you create a thread, right, it goes to another, like another space, and it starts recording. Then what it does is it closes the foreground notification under that 5 seconds. So if you start foreground notification, then you start, the old bypass used to work like this. You start foreground notification, you give like a call to the media server, it starts recording, and then it stops the foreground notification. But it takes time. It takes more time than 5 seconds, right? So Google patched it, and what I did was I started a thread here. You started runnable, and once you start a thread, under that you have to run the start recording call. Once the start recording call is done, it will record for 2 minutes, and then it will. So basically, the code only understand the Android. What Android is seeing is there's a start foreground, there's a thread, right? Once the start foreground is called, the thread goes to another space, so it do not have any connection with the this. It will not be on the main process, right? On the main application thread. So it goes to another space, and it directly stops the foreground notification. So basically, it's starting and stopping the foreground notification within like 2 or 3 seconds. So it doesn't take like 5 seconds. So it works like that. So this is how it is working. I'm starting the foreground notification service here, and what I'm doing is I'm starting the thread right after that. And what it does, whatever we are going to do, like the camera snaps, the camera location, and sorry, not the camera location, camera, microphone, and the location, right? Whatever we are doing, we'll have to do under that thread, and we'll have to stop the foreground notifications after that. So so we'll see how exactly it works. We'll have a demo. Fine. So here's the code I wrote. 1 second. So I have connected my USB cable with it and USB debugging is enabled, but in real life scenario, you do not need it. I just connected it to show the logs out here. So it's not needed basically. So I'll be installing this application. So first I'll be installing the application with the old bypass, which is this. And then I'll start with my new bypass, which I did. So I'll just comment it out and I'll install the old bypass first. So this is the application. So I'll just allow this. I'll close the application. You'll be able to I'll close all the application. It's running in background. So these are the logs. We'll follow the logs to understand how it's working. So we'll have to wait for like 2 minutes. So this is basically the old bypass, and it does not work now. And I'll show you how this looks right now on Android 10. So it takes around 2 minutes to get started because I have closed the application. So what this code does is it tries to access your microphone and then start recording. So it started like, so the race demo is starting, and you can see the notification do not vanishes, right? And this is exactly where you can understand that your someone is trying to access your microphone, or someone is trying to do something with your phone, right? This is the old bypass and do not works on current Android 10. So I'll just comment this out, and this is the new code. This is the new bypass. So I'll just reinstall it. So this is I have reinstalled the application, and I'll close it. So we'll have to wait for more 2 minutes. So the phone is very slow, and that is why you'll able to see you'll be able to see the notification, and then it will vanish. But in the modern phones, right, you'll not be able to spot it. So it will take around 2 minutes to start. So it is starting the, so it's starting you can see this, the race demo is starting. 1 second. So you can see it vanishes, right? It just started and it vanished. So I'll show you how the recording is being saved. I'll go to files, and so what we already have learned, right? So what it does is starts the foreground notification, it calls the recorder, and then it stops the notification, right? It's still recording, and we can't see it over the notifications. You can see there's no notification of recording. But if you go to data and you search this application, and you'll see a folder, and you can see cache. You'll see the recordings are there, right? It started recording, and if you refresh, you can see the size is increasing because it's currently recording. Can you guys see? Can you guys? You can see it's still recording, right? So this is how the bypass is working. You'll see there are new recordings added. So there's no foreground notification. See, it will just vanish. But in modern phones, right, you'll not even able to spot it because it's very, very fast. So so guys, thank you. And thank you guys. So if there are any questions, you can ask. Any question, guys? Okay.
Hello. First of all, thanks for the talk. I really enjoyed it. And so my question is, so I saw that you were spawning the thread multiple times in a loop, right? So was it for keeping it alive?
No, it's basically the time frame is there, right? The 5 seconds of time frame. So you'll have to call it between that particular time frame. So that is why what I'm doing is I am starting the thread so that it goes to another space and it directly stops the notification. So it's done under like 2-3 seconds. So that is why I'm using the threads for the bypass.
Okay, so to increase that time, right?
To increase, yeah,
To
yeah,
keep it
right.
alive. Okay. Thank you.
Thank you for your. Any more questions, guys?
Anyone else? I just want to ask that this is working for Android 10 and above for all, right?
Oh, the interesting thing about this talk is the bypass is still the bypass still is working and still works up to Android 10. Google told me that they will not fix it. So basically, to fix it, right, to fix this bug, there's a lot of infrastructure changes has to be done. So it will still be there. The bug will be still be there.
Like what about Android 11 and 12?
Android 11, they fixed it. So because it's not fixed in Android 10, right? I have not received any CVs for that. That is the reason for not receiving any CV.
Okay, thank you.
Thank you so much.